All right, picture this. It's 2 in the morning. You're standing in some muddy distribution yard. It's raining sideways because let's be honest, in this job, it's always raining when something breaks.
It's a rule of the universe, I think.
It has to be. You walk up to a reefer unit. It's humming away, supposed to be protecting, high-value pharmaceuticals, maybe 20 tons of frozen seafood. And then you see it, that dreaded amber light just flashing on the status bar.
The universal signal that your night just got a lot longer.
And your coffee just got a lot more necessary.
Yeah.
Exactly. You look at the display and there it is, alarm code 003. Now, to the uninitiated or maybe to the driver just trying to get on the road, that's just a number. It's an obstacle.
Right.
But to a pro, that number is the title of a mystery novel.
It absolutely is. And it's usually a story about the unit losing its primary sense of touch. If you don't know how to read that story, you're just going to be throwing parts at a machine that's trying to tell you exactly what's wrong.
And that is our mission on this deep dive. We're looking at a stack of technical manuals, service procedures, all that, to decode alarm code 03. Check return air sensor. But we're going to do this a little differently today.
Oh, yeah. How's that?
I'm going to play the role of the trainee. I've got my multimeter, I've got a pair of wire snips that I'm probably way too eager to use, and I just want to clear the code and go home.
And I'm the senior technician, the one who's going to stop you from cutting the blue wire when you should be checking a connector pin.
I feel like that's a true story.
I like that dynamic, because in this field, the how is actually the easy part. Anyone can unscrew a sensor and screw in a new one. The why. That's what keeps the cargo safe and keeps that unit running for 10 years instead of 2.
So, challenge accepted. We are not just here to clear a code. We're here to understand the difference between a hard failure and a soft failure, master the wiring hierarchy so we aren't guessing, and figure out why, spoiler alert, you can't just hit clear on this code without passing a pretty serious logic test first.
That logic test is the gatekeeper. It trips up more technicians than almost anything else, but we'll get there. First, let's understand the patient on the table.
Right, the anatomy. So alarm 03 points specifically to the return air sensor. Now, based on schematics I'm looking at here, this is a pretty small component, just a little plastic barrel with 2 wires.
Yep.
In the grand scheme of a massive diesel refrigeration unit, how critical is this tiny piece of plastic?
You could argue it's the most critical reference point the entire unit has.
The most critical.
Oh, absolutely. Think of the return air sensor as like the unit's brainstem. It sits right in the return airstream.
So that's the air being sucked back into the unit after it's circulated through the trailer.
Exactly. It's telling the computer, this is the actual temperature of the product right now.
Yeah.
Based on that one number, the unit decides whether to cool, to heat, or to go into null. If that sensor is wrong, every single decision the unit makes after that is wrong.
Okay, so high stakes. Now, if that sensor fails, if alarm 03 triggers, does the unit just give up? Does it, shut down to protect the load?
No, and that's a very common misconception. These units are built for survival. They're designed to keep the load alive at all costs.
Okay.
So if the primary brain, the return air sensor, goes offline, the unit switches modes. It triggers what we call alarm code 11.
Alarm code 11. Unit controlling on alternate sensor. I see that in the troubleshooting tree here. So alarm 03 and alarm 11 are basically holding hands.
Almost always. When code 03 hits, the unit effectively says, I can't trust the return air anymore. It's gone. So I'm switching to discharge air control.
So it starts using the sensor that measures the air, leaving the unit instead.
Precisely.
That sounds like a reasonable backup plan. I mean, why is that a problem?
It's better than nothing, but it's a very blunt instrument. Imagine trying to heat your house based on the temperature of the air inside your furnace, not the air in your living room.
Right.
Discharge air is always much colder or much hotter than the actual cargo temperature, so the unit has to guess a lot more. You risk freezing the top of the pallet while the center is still warm.
So it's basically limp mode.
It's survival mode. It keeps the load from spoiling in the short term, but yeah, you're flying blind. You still have that flashing light, and you need to fix it before the cargo integrity is compromised.
All right, let's get into the fix then. I'm the trainee. I've got the side doors open. I'm staring at a harness that looks like a bowl of spaghetti. I need to find the wires for the return air sensor. What am I looking for?
Okay, get your schematic out.
Yeah.
We're looking for a simple 2-wire circuit. It's not complicated, but it has to be precise. You need to find the base controller, and that's the main computer module.
Right.
We're looking for the 35-pin connector. It's labeled J3.
J3. Okay, I see the J3 connector. Now, there are 35 pins here. I assume I'm not just poking around randomly with my meter.
Please don't. That is a very fast way to blow a controller. You need pin 1 and pin 2.
Pin 1 and 2.
Pin 1 is your positive side. The wire label you're looking for is RTP01.
RTP. I'm guessing that stands for return temperature positive.
You got it. That connects to the blue wire on the sensor itself. Then you have pin 2. That's the negative side, labeled RTN01. That goes to the brown wire.
Okay. Blue to pin 1, brown to pin 2, that seems straightforward. But looking at this harness physically, on the actual unit, everything is wrapped in black loom. I can't see any wire labels without slicing everything open.
Right.
Is there a cheat code? How does a senior tech spot this specific sensor cable without stripping the whole harness?
There is a visual trick, actually. It's not in every manual, but it's part of the manufacturing standard. If you look at the harness near the sensor connection points, you should see a single yellow cable tie.
A single yellow zip tie, just a random one.
It's not random. It marks the return air sensor wires in the harness. It's a quick visual identifier.
See, that is the deep dive nugget right there. Look for the yellow tie. That probably saves, what, 10 minutes of digging?
It saves you 10 minutes, and it saves the harness from getting butchered by a trainee's knife.
Touché. Okay, so I've identified the wires. I found the yellow tie. I've got my replacement sensor in hand. I'm ready to install it. I just plug it in, zip tie it to the bracket, and we're good to go, right?
And that right there is exactly how you guarantee a callback in 3 months.
Uh-oh. What did I do wrong now? I connected blue to blue and brown to brown.
You connected the wires, but you didn't respect the physics of moisture. There is a golden rule in sensor installation that you need to tattoo on your brain. Barrel up, wires down. Barrel up, wires down. Okay, it sounds like a mantra.
It has to be. The barrel is the actual sensing element, the plastic shell that holds the thermistor. Yeah. You want that pointing up, or at least positioned, so that the wires coming out of the back of it are pointing down.
Why? Is it an airflow thing? Does it need to catch the wind or something?
It's a gravity and capillary action thing. These units operate in extreme environments. You've got condensation, rain, pressure watch.
If you mount that sensor with the wires pointing up, gravity will pull any water droplets right down the wire insulation.
Oh, and it goes right into the back of the sensor.
Exactly. Water is tenacious. It will wick its way right inside that shell.
And I'm guessing water inside a precise electronic component is bad news.
It's fatal, but not in the way you'd think. It doesn't usually cause an immediate short. It causes the readings to drift. It corrodes the element slowly. It changes the resistance. This is the #1 cause of what we call soft failures, which are the most dangerous kind.
Okay, we have to get to soft failures in a second because that sounds ominous. But first, I noticed something else in the parts box. The new sensor has a tag on it. It says grade 4 or grade 5. I thought a sensor was a sensor. I can't just grab anyone off the shelf.
Well, you can physically plug it in, but the computer's not going to like it. Or rather, it won't understand it. These things are precision thermistors. It's impossible to manufacture every single one to have the exact same resistance at the exact same temperature. There are tiny manufacturing variances.
So the grade is basically telling the computer how to correct for that variance.
Exactly. It's an offset. You have to tell the base controller what grade of sensor you just installed. It's like calibrating a scale.
What happens if I don't? What if I just plug in a grade 5 sensor but leave the computer set to grade 3 or whatever it was before?
You're going to introduce a permanent error in the reading. The unit will think it's warmer or colder than it actually is. But even worse, you might run into the 5H trap.
5H trap. That sounds like a cryptic error message.
It is. If the system defaults or if you reset the configuration, sometimes the grade setting might show 5H on the display. Now, 5H is not a valid grade. It's a placeholder.
Okay.
If the controller sees 5H as the grade, it triggers alarm code 92. Sensor grade's not set.
So now, instead of fixing my one problem, I have alarm 03 and alarm 92.
Correct. And the unit will not run properly. You have to go into the guarded access menu, the technician-only menu, find the sensor calibration menu, and physically input the actual grade printed on the new sensor's tag. Only then will alarm 92 clear, and only then will the math be right.
It's like installing a printer driver. You have to tell the computer what it's talking to.
That is a perfect analogy. Without the right grade, the translation is just wrong.
All right, so we have the sensor installed properly, barrel up, wires down, grade is set. But let's back up a second. How do I even know the sensor is bad in the first place? You mentioned soft failures and hard failures. To me, broken is broken. What's the difference?
This is where diagnostics get really interesting. A hard failure is usually what triggers the panic. It's obvious. It's the unit screaming for help.
And what does that look like on the display?
You'll see dashes, just 3 dashes right across the screen where the temperature should be.
And what does that mean electrically?
It means the reading is wildly out of bounds. The logic is programmed so that if the sensor reads above 200 degrees Fahrenheit or below -50 for just 10 seconds, it declares a hard failure.
Okay, so if I'm hauling frozen chicken and the sensor suddenly says it's 200 degrees in there, the computer knows that's physically impossible.
Exactly. It knows it's a lie because of the physics. That usually means you have an open circuit, like a wire got cut by a forklift or a short to ground. The circuit is broken. Infinite resistance or zero resistance. That's a hard failure.
That seems easy enough to diagnose. You find the break, you fix it. But you called the soft failure the silent killer. Why?
Because in a soft failure, the sensor's still talking, it's just lying. And it's a believable lie.
Oh, that's much worse.
Much worse. In a soft failure, the reason is erratic or it drifts, but it stays within that 200 to -50 degree range. So the computer doesn't immediately flag it as impossible, it just thinks the temperature's changing.
So the unit might think it's, say, 40 degrees inside when it's actually 50 degrees.
Right. And just think about the consequences. If the sensor directs low, it tells the unit, hey, it's 30 degrees in here, but it's actually 45 degrees.
The unit stops cooling. It thinks the job is done.
And meanwhile, your cargo is spoiling. Or the reverse, it reads high, thinks it's hot, and runs the unit in high-speed cool, freezing a load of produce that should have been kept fresh.
This is where alarm code 13 comes in, isn't it?
Exactly. Alarm 13, sensor calibration check. The engineers realized they needed a way to catch these believable lies. If the system detects that the sensor is drifting or acting erratic, jumping up and down without a logical reason, it sets alarm 03 and alarm 13.
So if I see code 03 and code 13 together, I'm likely dealing with a sensor that's dying a slow death, maybe from that moisture we talked about.
Precisely. It's not dead yet, but it's unreliable. And an unreliable sensor is way more dangerous than a dead one because it can fool the unit into doing the wrong thing.
Okay, that makes sense. So let's say I've diagnosed the problem. It was a soft failure. I swapped the sensor. I fixed the wiring. I double-checked my grades. I'm feeling good. I want to clear the alarm and go home.
Hold on there. You can't just go to the main menu and clear it.
Why not? I fixed it. The light is still flashing. I just want to make it stop.
This is a critical safety feature. Alarm code 03 is a check alarm, but because it involves the primary control sensor, you can only clear it from the guarded access menu. The system wants to make sure you really, really know what you're doing.
Okay, fine. I'm a pro. I go into guarded access. I hit clear. Does it go away then?
Not instantly. When you attempt to clear alarm 03, the unit initiates a logic test. This is the part that trips up so many technicians who think they're done.
Logic test? What?
Sure.
It's quizzing me.
It's quizzing the physics of the box. We call it the 30-degree rule.
The 30-degree rule. Okay, let's unpack this.
When you command the system to clear the alarm, it takes a snapshot of 3 sensors at the same time. The return air sensor you just fixed, the discharge air sensor, and the evaporator coil sensor.
Okay. 3 sensors, 3 data points.
And it compares their readings. They must all be within 30 degrees Fahrenheit, or about 17 Celsius of each other.
All 3.
All 3. If the spread between any of them is wider than 30 degrees, the unit refuses to clear the code. It assumes that one of the sensors is still inaccurate.
Wow. So it forces a sanity check. It's basically saying if the air coming in is 30 degrees different from the air going out, something is physically wrong.
Exactly. Or if the coil is 50 degrees colder than the air, we have a problem. If they aren't close enough, the alarm stays active and it'll throw alarm code 13 again to tell you, hey, your calibration is still off.
Wait, play this out for me. What if I just finished a repair and the trailer is hot, say it's 80 degrees inside, but I just ran the unit for a minute so the coil is now freezing cold, maybe 20 degrees? That's a 60-degree spread.
Correct, and you will not be able to clear that code.
Even if the sensor's brand new.
Even if it's brand new, the machine doesn't know why the spread is there. It just knows the spread exists. So as a technician, you have to wait. You have to run the unit, let the air circulate, let the temperature stabilize and come closer together. Only when they're within that 30-degree window can you clear the alarm.
That is frustrating,
Right.
but I get why it's necessary. It stops you from driving away with a unit that still can't tell the truth about the temperature.
It forces you to look at the whole system, not just the one part you replaced. It connects back to what we said at the beginning. You have to understand the story the machine is telling you.
Speaking of the story, let's talk about how we read the history. You said earlier the senior tech doesn't guess. The trainee guesses. The senior tech knows.
Never guess. We use data. We move beyond guessing by using the tools available, specifically WinTrack and the Service Watch data logger.
For the listener who hasn't plugged a laptop into a reefer unit before, what is Service Watch?
It's the unit's black box. It records all the sensor data over time, temperature, mode, alarms, every few minutes. When you have an alarm 03, especially a soft failure where the sensor was drifting, Service Watch is your best friend.
What am I looking for in the data? I open up the graph. It looks like a stock market chart.
You want to look at the exact moment the alarm was set. WinTrack lets you pinpoint that timestamp. Then you look at the grass shape. Did the temperature spike instantly, like a vertical line?
Which would indicate
An electrical issue.
Yeah.
A wiring problem. A loose connector. A vibration causing a momentary short. Temperature doesn't naturally jump 50 degrees in 1 second. If the graph looks like a square wave, it's electrical.
And if it's a slow curve?
If you see it drifting slowly over time, separating from the other sensors, like the return air is slowly creeping up while the discharge air stays flat, that's sensor decay. That's moisture intrusion. That's a soft failure.
And you can see all of that without even picking up a screwdriver, just by looking at the data first.
Exactly. You can see if there's a history of intermittent codes. Maybe this unit has thrown code 03 5 times in the last month, but it cleared itself. That tells you there's a loose connection or a connector pin that's backing out.
Which brings us to service procedure, D01A. The manual mentions this specifically for checking connectors.
Right. If you have intermittent issues, those are the worst ghosts to chase. You need to physically inspect the pins in that J3 connector. Are they corroded? Are they loose? The data log tells you when it happens, which helps you figure out why.
It really is about being a detective. The sensor is just the victim. You have to find the culprit.
It is. The parts are just the evidence.
So let's recap what we've learned today. This is not just about swapping a $50 part.
Far from it. We started with the hardware, base controller, connector J3, pins 1 and 2, blue and brown.
We talked about the installation physics. Barrel up, wires down. It's simple, but it stops the moisture that kills the sensor.
We covered the failure modes, the hard failure with the dashes on the screen, the open circuit, and the soft failure, the drift. The believable lie.
And we covered the big one, the logic test, the single degree rule. You cannot clear alarm 03 unless the return, discharge, and coil sensors all agree within 30 degrees.
That's the key takeaway. The system demands consensus. If the sensors don't agree, the alarm stays.
It effectively stops you from being lazy.
It stops you from being dangerous. Because remember, if alarm 03 is active, the unit is in a fallback mode. It's controlling off the discharge air, it's limping. Fixing it properly restores the unit's primary brain.
It preserves the integrity of the cargo. And at the end of the day, that's the only thing that matters. Whether it's ice cream or insulin, that sensor protects it.
Exactly.
Now, before we sign off, I have a thought. Bit of a nightmare scenario to leave our listeners with. We're talking about deep dives, so let's go to the bottom of the ocean on this one.
Well, let's hear it.
We know the unit compares the return air sensor to the discharge air sensor to check for validity. It needs that 30-degree window.
Yeah.
But what if both sensors start to drift? What if they both start reading 10 degrees warmer than reality, but at the same rate? Maybe from a systemic electrical issue, a bad ground on the board, or just incredible bad luck with two old sensors.
That is a terrifying thought. That's what you'd call a sympathetic drift.
If they both drift but stay within 30 degrees of each other, the machine passes the logic test. It thinks everything is fine, but it's hallucinating.
At that point, the machine has no idea it's wrong. It would cool the cargo down to what it thinks is the set point. But in reality, you could be freezing produce or melting ice cream. The machine is confident, but it's completely wrong.
And that is why, no matter how good the computer is, we still stick a manual thermometer in the load during a pre-trip.
Trust but verify, always. Computers are smart, but they don't have common sense.
On that happy note, keep your sensors graded, keep your wires down, check that service watch data, and for the love of all that is holy, look for the yellow zip tie.
See you on the next deep dive.